We have a two-part presentation like last year with me, myself. I'm Will Schwartz, ORH weatherman on the board. And the other presenter in this little workshop is going to be Mike Nexter on Eastern. And we're doing a two-part mesoscale winter forecasting workshop here. I'm going to be focusing on freezing rain, sleet, and transition events. I know it's not as exciting for some of you snow weenies. But, and then Mike Exter here is going to be doing the real fun stuff with snow banding, heavy snow, CSI, all that stuff that goes in big KU events, big snowstorms. And he will be doing that as the second part of this presentation. So if you'll just bear with us for the next hour to 90 minutes, we can get you out of here and you guys can go to the bar. Alright, so as I just said, this first part of this event is mesoscale aspects of ice and transition winter weather events. And I'm sure a lot of you are familiar with these in the past couple of years. In the southern New England threads, we've been calling them Southwest flow events. And yeah, or disasters.
With a t-shirt.
With Extra's t-shirt. And what that is it's quite obvious as it says transition. We usually see several types of precipitation, and let's get this show on the road. I don't have a clicker with me, so I'll have to do it like this. This is just a quick review of the basics. This was part of last year's presentation. Some of you might remember. I went over where you're going to get sleet and where you're going to get freezing rain. And they're similar precipitation types, but they both have drastically different effects on our population and everyday life. Of course, the freezing rain is much worse. Freezing rain, for those of you who are pretty new to weather, that's the glaze that you get on the trees. It sticks to all your railings and icicles hanging off everything. The sleet is the ice pellets, and those don't stick to the trees and everything. They just accumulate on the ground as little balls of ice, and they're much less dangerous than freezing rain. But just as a basic, we already went over this last year, so I don't want to spend too much time on this. What you have in each type of precipitation with sleet or freezing rain is you have an elevated warm layer. Now what that means is that in most of these situations, the surface is freezing. It'll be 28 degrees at the surface. It could be 20 degrees. It could be 31, 32. It could even be 10 degrees in sleet. That happens sometimes. But what happens is that when you get further up into the atmosphere, there's a warm layer, and that's what's causing this weird precipitation type rather than snow. As the snow falls into this warm layer, melts into water, and the water becomes super cooled and either refreezes before it hits the ground, and that's sleet, or it hits the ground as rain, but as super cooled rain, and as soon as it makes contact, it freezes. And that's when it basically splatters and freezes, and that's what makes a glaze of ice. And again, here's just the differences between the two. The sleet usually has a thinner warm layer, and the deeper cold layer underneath it. It gives enough time and a cold enough temperature to refreeze the raindrops into sleet pellets. Whereas the freezing rain, the depth of the shallow cold layer below that warm elevated layer is usually less than 100 millibars. And so it's a shallower layer, so it doesn't give enough time for that rainfall to refreeze into sleet. So what you get is freezing rain, which is much more dangerous. And freezing rain has a lot more mesoscale aspects to the forecasting than sleet. Sleet is a much more of a synoptic precipitation, where you're looking at the 850 low track, you get too much warm air intrusion. Whereas freezing rain, there's a lot of weird things that can happen. I'm going to give a couple of case studies here. One of them was the December 2008 ice storm up in New England, and the other one is going to be actually a small event that was in the Washington, D.C. suburbs in January of this past winter, January 6th and 7th, 2009. And there were very small-scale mesoscale aspects in each event that created drastically different weather depending on where you lived, and they were freezing rain events. So jumping ahead quickly here, let's go over transition events first before we get onto the freezing rain. Again, as quite obvious as the title suggests, it's transitioning, so you have more than one precipitation type. Most often on the East Coast, you go from a colder precipitation type to a warmer precipitation type. And the reason for that is that usually when you're transitioning back to a colder atmospheric profile on the East Coast, it's usually drying out. So you don't really get as many big, rain to snow events on the East Coast. You do get them. We all remember some of the ones like Christmas '02. For those of you who live in New York City or down in New Jersey, it started as rain, went over to snow. But for the most part, it's usually starting as snow, and then we go over to sleet, freezing rain, and eventually rain. Because when we get a colder northwest flow, the air tends to dry out on the east coast due to the mountains to our west. So generally, this is the rule most of the time, and of course, there are a few exceptions. Sleet is the most common we see in the transition events. As I'm sure all of you are aware, the last few winters there's been plenty of sleet along the east coast. And that's because the synoptic setup's been very favorable for sleet the last few winters. We've had sort of a southeast ridge and a southwest flow coming right into the northeast, so a lot of these storm systems are running right along that flow. And sleet is the most common type you see during a transition event. And most of the time, the sleet lasts for a few hours and then you eventually go over to rain. For the most part, of course, Valentine's Day 2007 was a lot different. Coastal fronts can play a role where the precip stays frozen. Now again, as I said before, sleet is not very mesoscale in nature, so I'm not going to harp on this very long. It's generally a synoptic thing, but you can get some weird coastal front situations where it'll be in the teens and 20s inland sleeting, and the coastline might be 34 in rain. And one of the setups of that was this storm here, December 16, 2007. What I drew here is I basically drew where the coastal front was. And for those of you, for anyone who can't see very well, if you want to look at any of these images after the presentation's over, I'll be happy to show you if you can't see that well. But I think you can get the general idea here. What you see here along the coast, look at the wind direction. It's all coming in out of the straight east. Now it's funny because there's a southeast wind over here way back in the interior, western PA and western New York. This is where the primary low was, but there was a little secondary low that tried to pop here. And that's why you have the east winds all along here. And then notice here, from Maine, look at that northeast flow from Maine down into interior southern New England, and even the northwest wind flag there in Sussex, New Jersey, I think it is. And then going down into Allentown, Pennsylvania, and then down even into interior northern Maryland. You see a north wind, and if you look at the odds, it's all 19 degrees in Sussex, New Jersey, 25 in Allentown, freezing rain, sleet going on here, and it's even still snowing before it changed to sleet here in interior New England. But you see you got 30 degrees in Boston with an east wind, Worcester just 40 miles west to 13 with a north wind, and then New York City's raining at 35, but then just 40 miles west in Sussex County, it is 19 degrees and freezing rain. And so that's an example here of just a mesoscale, an important mesoscale feature in this storm that creates a large difference between precipitation type and, of course, impact on the public and travel, things like that. So that's one example that's not totally freezing rain related, where you can still get rain along the coast and it'll be sleeting a little bit inland. But then you see mid to upper 40s down here in central southern New Jersey, just on the other side of the